Guys, for all the solutions of this book, visit forthesakeofeducation.com. I've been working hard of putting all the problems into one convenient place for you to be able to do your homework easily. So pay us a visit.
Alright guys, let's do this problem that says a boy stands out at the end of the diving board which is supported by two springs, A and B, each having a stiffness of K at 50 kilonewtons per meter. In the position shown, the board is horizontal. If the boy has a mass of 40 kilograms, determine the angle of tilt which the board makes with the horizontal after he jumps off. Neglect the weight of the board and assume that it is rigid. Alright, so to do this problem, we're gonna say that you know that the boy is creating a force, let's call it W for his weight, and it is equal to the 40 kilograms, which is given in the problem, times the acceleration of gravity, which is 9.81 meters per second square, which means that the weight is equal to 392.4 newtons. If this force is going down, this force is gonna react up, and it's gonna be F of B. And then since this one's going up and the boy's going down, they're basically trying to tell this whole structure like so. So the reaction at A is gonna be to hold it back at F of A. And this is our first diagram that we're gonna do in order to be able to find the forces. So let's find F of B and F of A. Now, I'm going to do sum of the moments at A, and I'm going to set them equal to 0 and find F of B. You could also do sum of the moments at B and find F of A. Same thing, I'll just prefer this one. So assuming counterclockwise is positive, sum of the moments at A is equal to 0, and it is equal to F of B times 1. Why times 1? Because it's F of B times this distance from B to A, which is 1 meter, minus the moment being created by the weight, which is the whole length of the board times the weight, which is weight times 4. And it's negative because it's trying to turn it clockwise, whereas F of B was trying to turn it counterclockwise, so it's positive. So if you solve for F of B, you're going to get that F of B is equal to 1569.6 newtons. Remember, we found the weight before and we just plug it into here, and then we solve for our only variable, which is F of B. Now let's find F of A. Sum of the, not sum of the moments, but sum of the forces in the y direction is equal to 0. We know that F of A is going down plus F of B, which is going up, minus the weight. We have the weight and we have F of B, which is founded. So we plug those numbers in and we're gonna get that F of A is equal to 1177.2 newtons. Now comes the bit of interesting part that this problem has, which is that, let me see if I can lower the opacity of the drawing to help you visualize this. But basically, at the point in which the boy jumps off, after that's important, after he jumps off, the board is going to look a little bit like that. Maybe it's exaggerated, but you get the idea, right? And this angle, or this angle right here, is the angle that we're trying to find, right? So, or let me write it like this angle also. So I'm going to redraw the board over here. And we have the spring was on, and this was the original state of the board, right? And let me improve my drawing skills over here. Okay, so let's say this is the B spring and this is the A spring. Let's put them all the way down here, the A spring. And you're basically trying to find this, but what you have to understand is that the distance that the A spring was compressed, it's LA, and the distance that the B spring was stretched, let's call that LB, right? And we know that this triangle right here, I'm going to extract it and redraw it over here, and it's going to look something like this. This distance right here is 1 meter, and it is given right here. And this distance right here is LA plus LB. So if we knew, and this is theta, and if we knew LA and LB, then we could find beta by doing the tangent inverse. We would know that beta is equal to the tangent inverse of LA plus LB all over 1 meter. So that being said, let's find LA and LB, which is really easy because we do have the forces. You know that F of A is equal to LA times K, which is a constant that is given right here. So F of A, which is 1177.2, is equal to LA, which is what we're trying to find, times K, which is 15K. So LA is equal to 1177 divided by 15,000, which is 0.07848 meters. Then we follow the same process for LB times K. LB is 1569.6. LB times 15,000. LB is equal to 0.1046 meters. So if you add them together, you basically plug them into this formula and do the tangent inverse of the sum of LA and LB divided by 1, which is the same number, and you should get that theta is equal to 10.37 degrees. Final answer.